Hello everyone. Thanks for your time to listen my presentation. Here is my final year project, and my final year project is mainly focusing on person recognition and their unconstrained environment. Nowadays, the face recognition techniques based on convolutional neural network have achieved a great success. There have been various mature applications widely used in normal life, but recognizing person and their unconstrained environment still be an open challenge. Issues like unfavorable lighting, occlusions, non-frontal faces, or even covered faces can significantly affect the recognizing accuracy. Actually, like this picture showing just an example. In human perspective, when we want to recognize someone's identity, the most discriminative characteristic is on his face. But in real-world photos, first we could not guarantee the appearance of face. They might be occluded, or the photos is from back view, or even some makeup. For example, the airman got his mask on his face could lead the misunderstanding. In this case, the wearing would be the most discriminative characteristics in first two image we could see, and we might use this feature to recognize the identity instance identity. Second, it is normal that some region of the body is out of scope. For example, the lower body of these two pictures. So even for the same identity, the sample of it would vary across the instance. To address this issue, recognizing person by region separately become a very neutral idea. So in this project, I proposed a framework called Region Attention Network to try to solve this problem. Let me give you more examples. Like we cropped the instance into 4 regions: face, head, upper body, and the whole body. In figure 2, we could see that some region of the instance are missing, for example, the lower bodies. And in previous work, like SpandelNet, have already shown that the situations like figure 2a could be effectively addressed by the region-based learning network, but existing work treats the region in same weight. The weight depends on not only the image clearness, it is very common size, but also the virtual context. What is virtual context? It's like when recognize people at the most time, face that would be the most discriminative region, like we just mentioned. But when we cover the face, we still got some clues from the image. Like the clothing you dressed up like a suit is more outstanding than the pure color T-shirt, or even naked like Leonard. Okay, because actually for human, if you are naked, uh, actually everyone seems very similar, and here the instance-dependent weight could help. Of course, face should dominate the result if possible, but if we could not see the face, the other region need to help, like samples in 2a. The weight should be different for different regions in a single instance. Also, even the region exists, the contribution of regions vary across instances like the face and upper bodies in 2b. So that's why we call it instance dependent. The framework details is like this. The whole network could regard as two stages. First is feature extraction stage. In this stage, face, head, upper body, and whole body region would feed into one CNN as input. This CNN is actually based on Restat 101, which is a very famous and common used CNN structures nowadays, and we use online instance matching loss function instead of normally used cross-entropy loss functions. Both of ResNet and OIM loss function could speed up the convergence when we train the network. That will solve a lot of time of it. And also, as OIM loss might easily lead the network overfitted, so instead directly use 2048 dimension feature vector output by ResNet 101. We reduce the feature into lower dimension 256. Each region would extract one 256 dimension feature vector. And second is the feature fusion stage. In this stage, the learned region feature vector from previous stage would feed into the feature fusion network. The network would learn the instance-dependent weight for the specific instance regional vectors. The output would be collected by the classifier so that we could recognize the identity of the instance. Actually, here is the network details. It is very low level, so we skip it. And here is the experiment. Actually, we use my existing dataset to train our framework, which is people in photo albums, or PIPA shortly. In this image set, only about half of the person images contain a photo face. The recognition task is very challenging due to the large variance in pose, closing, camera, viewpoint, image resolution, and illumination. The dataset totally contains 52,000 instances belonging to 2,400 identities like this, and the training subset contains about 39,000 instances, and the test subset contains 13,000 instances respectively. The dataset detail is shown in table. From the dataset, we could see about 30% instance could not be detected the face region, 20% instance could not be detected head region, 70% instance could not be detected upper body, and 38% could not be detected whole body. So it is a very challenging dataset for us to do the face recognition. In order to show our framework's improvement comparing the existing outstanding work, we run three different models on this dataset. First, we use body region feature network individually with nearest neighbor classifiers as the baseline model. This baseline model could be regarded as one traditional standard end-to-end CNN person classification model. If all instances have the region, this network could achieve a satisfactory performance, actually, like around 80% accuracy. But on this dataset, as the result is shown in the second column, we could see that the unconstrained environment could decline the accuracy in a magnificent way, if you not even close to 50%. Then we test the spatial network's performance in this experiment during the classification. We not only use the nearest neighborhood classifier or k nearest neighborhood classifier. We also append one fully connected layer to adaptively map the features into the label space. This is actually the rough idea about the instance-dependent weight. We could see it could achieve an outstanding improvement already. At last, is our regional attention network actually. In this experiment, all the models using the nearest neighbor classifiers because of easy implementing and comparing. The result is shown here. We could achieve about 8% accuracy improvement based on existing outstanding network, from 61 to 69. or 71 to 79, sorry. And from the result of experiment, we could see that first, the instance-dependent weight with region attention network could outperform purist understanding method by a notable margin. And second, with the help of several classifiers, we could further improve the recognizing accuracy by objective degree. But we are now only leveraging the virtual context actually. And we could leverage more clues like the social context from the image to help us in recognizing. For example, the surrounding environment or the people nearby. Our network shortage is like we could not recognize twins with each other as the virtual context of them are almost the same. But with the help of social context, we could easily recognizing their girlfriend or boyfriend using the virtual context learning. Then we could speculate the identity of the twins as from their girlfriend or boyfriend, and meanwhile, if their hobby is different, like one like swimming, the other like reading, then the surrounding environment, like swimming pool or bookshelf, could also help us to recognize the person identity. But this is the further exploration, and actually, this is that's all about my presentation. Thanks for listening.